Bismillahirrahmanirrahim. Exercise 5.3, question number 7. Each unit of food X costs rupees 25 and contains 2 units of protein and 4 units of iron, while each unit of food Y costs rupees 30 and contains 3 units of protein and 2 units of iron. Each animal must receive at least 12 units of protein and 16 units of iron each day. How many units of each food should be fed to each animal at the smallest possible cost? Let's first of all write the given information in the form of a table so that we can find the inequalities and the cost function easily. We are given two types of food. The first type of food is the food X and the second type of food is the food Y. Then we have been told that what amount of protein and iron must each animal receive every day. So I'm going to write here that each animal must receive every day. Each animal must receive every day. Now, each food contains protein and iron, and of course, there is some cost for each food. Now, let's see. Each unit of food X costs rupees 25. So cost for unit food X is 25 per unit and contains 2 units of protein. That is, food X contains 2 units of protein and 4 units of iron, and it contains 4 units of iron. While each unit of food Y costs rupees 30. Cost of Y per unit is rupees 30 and contains 3 units of protein. It contains 3 units of protein and 2 units of iron. So 2 units of iron. And each animal must receive at least 12 units of protein. So 12 units of protein is the minimum requirement and 16 units of protein, 16 units of iron. So 16 units of iron. So it means that whatever food we give them, we give the animals, the sum of the protein must be greater than equal to 12. It must not be less than 12. It has to be greater than equal to 12, and the sum of the iron given to them by the two foods must be greater than equal to 16. Now let's start the proper solution. Let X units of food X and Y units of food Y, this is capital Y units of food Y are fed to each animal, then X has to be greater than equal to 0, Y has to be greater than equal to 0, and then X units of food X. So it means each animal will get 2X plus 3Y. Y units of food Y. So protein they will get will be 2X plus 3Y. It has to be greater than equal to 12. And for what about iron? The iron will be 4X plus 2Y. 4X plus 2Y. It has to be greater than equal to 16. And then what will be the cost? The cost function, let us name it as f of xy. So it will be the function to be minimized because we want to feed the animals at the minimum possible cost. So it will be equal to 25x plus 35. 25x plus 30y. And now we have got our question. That is, we have to minimize this function according to these constraints. And how we have got these constraints? Let me explain it again for you. We have taken X units of food X and Y units of food Y. So protein will become 2x plus 3y, and it has to be greater than equal to 12. And what about iron? Iron becomes 4x plus 2y, and it has to be greater than 16. What becomes cost? 25x plus 30y, and this is our cost function which is to be minimized. Now let's start the solution now. Here you can see the first inequality, 2x plus 3y is greater than equal to 12. Name it now number 1. Its corresponding equation, x equals to 0 gives y equal to 4, y equals to 0 gives x equals to 6. So these are the the x-intercept and the y-intercept. Put origin in 1, it is false. Result, origin does not lie in the solution region. The same steps for second inequality. Corresponding equation, x equal to 0 gives y equals to 8, y equals to 0 gives x equals to 4. Put origin in inequality number 2. Result is false. So origin does not lie in the solution region. And now we are going to draw both these lines. And the lines are, the first line is for, the points are 0, 4 and 6, 0. X equals to 0, y equals to 4. Here is the first point. At x equals to 6, y equals to 0 is the second point. Join the two with the help of a straight line. So we join the two with the help of a straight line, and then put arrowheads on the line. Here it is. And then write the equation of the line, which is 2x plus 3y equals to 12. Name it L1 and mention its solution region, as origin does not lie in the solution region. So one region is below it and the second region is above it. As a result, its solution region will be shaded on this side of the line. Let's go for the second line. And the second line is, the points are 0, 8 and 4, 0. X equals to 0, y equals to 8, x equals to 4, y equals to 0. Join the two with the help of a straight line. Here it is. Join the two with the help of a straight line. Extend it on this side. It is not extending. Let me do it again. Extend it on this side. Put arrowheads on it. This and this. Write the equation of the line, which is 4x plus 2y. 4x plus 2y equals to 16. Name it L2 and mention its solution region. Its solution region will be on this side of the line, because the one region is this and the other region is this, and origin lies in this region. But we have been told that origin does not lie in the solution region. So we are going to shade this side of the line. And now what? I'm going to shade these regions and then I'm going to show you. First of all, I'm going to shade the solution and x greater than equal to 0. Here it is. This is x greater than equal to 0 and this is y greater than equal to 0. So apply all these four constraints. I'm going to restrict my solution region in the first quadrant. Now I'm going to shade for L1. Here it is, students, the solution region of L1 in the first quadrant. This side of L1 has been shaded and we have restricted within the first quadrant. Now I'm going to shade the region for L2, and on this I will shade on this side of L2 and I will remain within the first quadrant. Let me show it to you. Here it is. Here you can see, students, that this area is the shaded region of the second inequality, this one, and the double shaded region, the darker region, it is showing the common region of the two inequalities. So of all the four inequalities, and let's mark the solution region now. It starts from here and then comes this and then comes this and this is an open region. Now let's mark the corner points. This is our first corner point. I'm naming it as A and its coordinates are x equals to 0, y equals to A. This is our second corner point. I'm naming it as B and I will evaluate it as the point of intersection of L1 and L2. And this is my third corner point. Its name is C and its coordinates are 6, 0. Now let's write all these corner points. We have got three corner points. The corner point A, which is 0, 8. The corner point B, which is the point of intersection. The point of intersection of L1 and L2, and the point C, its coordinates are 6, 0. Now let's solve these. Let's find point B as point of intersection of L1 and L2. Here you can see L1 is 2x plus 3y equals to 12, L2 is 4x plus 2y equals to 16. Solve the two simultaneously, multiply L1 by 2 and subtract L2 from it. As a result, you will get 4y equals to 8, or you may say y equals to 2. Put in L1 and you get x equals to 3. Simple calculations. Hence, the point B becomes 3, 2. Let's write this point on our graph. As we have mentioned all the corner points on it, let's write corner point B here, and it is 3, 2. And now we go to our original question. Original problem was to minimize the cost 25x plus 30y. This is the cost function. We have to minimize it. So what we are going to do now, we are going to evaluate this cost function at all these corner points. First of all, you can see I have made a table. Now I'm going to put A08 in it. As a result, I will get 25. Let's say 25 into 0 plus 30 into 8. And when you solve it, you are going to get 0 plus 240. As a result, the answer is 240. Then 25 at point B, put 3, 2 in it. 25 into 3 plus 30 into 2. As a result, you get 75 plus 60. The answer becomes 135. The last one, C60, put this corner point in it. As a result, you will get 25 into 6 plus 30 into 0. Result 150 plus 0, or you may simply say 150. Now I'll decide which one is the minimum. And I see that this value 240, 135, 150. Of course, this value is the minimum value. So the cost function will be minimum at the corner point 3, 2. Result, I'm going to write my result now. Hence, 3, 2 means 3 units of food X and 2 units of food Y. Hence, 3 units of food X and 2 units of food Y must be fed to each animal to maintain a minimum cost. That is, if we want to feed the animals at a minimum cost, then we must take 3 units of food X and 2 units of food Y, and that completes the solution. Here is a picture of the graph of that question. You can see it right now, and you can see here is, let me show you. You can see the scale taken here is 5 small scale equal to 1. This is x-axis, this is y-axis. This shows y greater than equal to 0. This arrow shows x greater than equal to 0. And then this is our first line L1. This is our second line L2. And these are all the corner points 0, 8, 3, 2, and 6, 0. You can see that if you are making drawing a graph on a proper graph paper with a perfect scale, then you can even calculate the corner point, this corner point from the graph. You can see here it is x is 3 and y equals to 2. And then the procedure, and that completes the solution.